Hello friends, welcome to C Programming video tutorials series. From the past few video tutorials, we are trying to understand operators in C programming language. We know that C provides rich set of operators to perform arithmetic operations, logical operations, comparison operations, etc. 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 In the previous video tutorials, we understood logical operators, arithmetic operators, relational operators, assignment operators, conditional operator, increment and decrement operators. In the next video tutorial, we are going to understand bitwise operators, guys. Bitwise operators perform operation on bits, that is zeros and ones. A bit means either 0 or 1, guys. Bitwise operators perform operation on bits, that is zeros and ones, guys. Bitwise operators convert the given decimal number or numbers to their binary equivalent number or numbers, and then they perform the operation on bits of those converted binary equivalent number or numbers, and then they convert and return the result of the operation as a decimal number back. Bitwise operators, what they do, they first convert the given decimal number or numbers to their binary equivalent number or numbers, guys, and then they perform the operation on bits of those converted binary equivalent numbers, and then they convert and return the result of the operation as the decimal number. So, to understand bitwise operators, we must and should understand two number systems. They are decimal number system and binary number system. Decimal number system. Deci means 10. Decimal number system has 10 digits, guys. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 to 9. As decimal number system has 10 digits, its base is 10, guys. To represent any number in decimal number system, we write sequence of these digits, guys. To represent 128, we write 8, then we write 2, then we write 1. To represent 65, we write 5, then we write 6, right, guys? Binary number system. Bi means 2. Binary number system has only 2 digits, 0 and 1. As binary number system has 2 digits, its base is 2, guys. To represent any number in binary number system, we write sequence of zeros and ones, guys. 0, 1, 0, 0, 0, 0, 0, 1 indicates 65 in binary number system. 0, 0, 0, 0, 1, 1, 1, 1 indicates 15 in binary number system, guys. You can see that just by seeing sequence of zeros and ones, it is difficult to say what number it represents, right, guys? So, we must and should understand how to convert a decimal number to a binary equivalent number. We must and should understand how to convert a binary number to a decimal equivalent number, guys. You can see that I have here decimal numbers 65, 15, 35, 40, 128. Let's understand how do we convert these decimal numbers to binary equivalent numbers, that is sequence of zeros and ones. To convert decimal number to a binary equivalent number, we write down 2 to the power series from right to left, guys. 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, 2 raised to the power of 4, 2 raised to the power of 5, 2 raised to the power of 6, 2 raised to the power of 7 and so on. 2 raised to the power of 0 is 1, 2 raised to the power of 1 is 2, 2 raised to the power of 2 is 4, 2 raised to the power of 3 is 8, 2 raised to the power of 4 is 16, 2 raised to the power of 5 is 32, 2 raised to the power of 6 is 64, 2 raised to the power of 7 is 128 and so on. You can see that I have stopped at 2 to the power 7, which is equal to 128, because the maximum decimal number I have here to convert is 128. If you need to convert higher than 128, then you may need to continue the series. 2 raised to the power of 8, 2 raised to the power of 9 and so on, guys. Let's convert 65 decimal number to binary equivalent number. What you need to do is, you need to find out those numbers. On adding them, you get 65 here. If we add 64 and 1, we get 65, right guys? So underneath 64, you write 1. Underneath 1, you write 1. Remaining places, you just put 0, 0, 0, 0, 0, 0. So 0, 1, 0, 0, 0, 0, 0, 1 indicates 65 in binary number system, guys. Let's convert 15 to binary equivalent number. If we add 8 plus 2, we get 10. 10 plus 4, 14. 14 plus 1, we get 15. So underneath 1, I write 1. Underneath 2, I write 1. Underneath 4, I write 1. Underneath 8, I write 1. Remaining places, I put 0, 0, 0, 0. So 0, 0, 0, 0, 1, 1, 1, 1 indicates 15 in binary number system. Let's convert 35 to binary equivalent number. On adding 32, 2 and 1, we get 35. 32 plus 2, 34, 34 plus 1, 35. So underneath 32, I write 1. Underneath 2, I write 1. Underneath 1, I write 1. Remaining places, I put 0, 0, 0, 0, 0. So 0, 0, 1, 0, 0, 0, 1, 1 indicates 35 in binary number system. Let's convert 40 to binary equivalent number. 32 plus 8, we get 40. So underneath 32, I write 1. Underneath 8, I write 1. Remaining places, I put 0, 0, 0, 0, 0, 0. So 0, 0, 1, 0, 1, 0, 0, 0 indicates 40 in binary number system. Let's convert 128 to binary equivalent number. Underneath 128, I write 1. Remaining places, I put 0, 0, 0, 0, 0, 0, 0. So 1, 0, 0, 0, 0, 0, 0, 0 indicates 128 in binary number system, guys. So that is how you convert a decimal number to a binary equivalent number, guys. There is one more way in which you can convert a decimal number to binary equivalent number, guys. Let me show that. Let's convert 15 decimal number to binary equivalent number, guys. I say 15, and then what you do, you divide it by 2, because the base of binary number system is 2, guys. 2 into 7, 14. Remainder is 1. 2 into 3 is 6. The remainder is 1. 2 into 1 is 2. Remainder is 1. Once you get at the last 1 or 0, you should stop further division, guys. And then what you do, you write down these digits from top to down, right to left, guys. We write 1, 1, 1, 1, 0, 0, 0, 0. So this indicates 15 in binary number system, guys. You can see that we have already converted 15 to binary equivalent. And what we have here, 0, 0, 0, 0, 1, 1, 1, 1. The same thing we got here, 0, 0, 0, 0, 1, 1, 1, 1, right? So this is one more way, guys. Let's take one more example. I say Control A and say delete. Let's take 35. Let's convert 35 decimal number to binary equivalent number. I'm going to divide it by 2. 2 into 17 is 34. Remainder is 1. 2 into 8 is 16. Remainder is 1. 2 into 4 is 8. Remainder is 0. 2 into 2 is 4. Remainder is 0. 2 into 1 is 2. Remainder is 0. Let's write down these digits from top to down, right to left. We write 1, 1, 0, 0, 0, 1. 1, 2, 3, 4, 5, 6 digits we have. Let me add 2 more zeros. So this indicates 35 in binary number system. We have 0, 0, 1, 0, 0, 0, 1, 1. If you see, we have already converted 35 to binary equivalent number. What we have? 0, 0, 1, 0, 0, 0, 1, 1. So that is how you convert a decimal number to a binary equivalent number, guys. I hope you guys have clearly understood. I suggest you people to try other examples. Let's understand how do we convert binary number to a decimal equivalent number, guys. You can see that I have some examples. Let's convert these binary numbers to decimal equivalent numbers. Again we write down same 2 to the power series 1, 2, 4, 8, 16, 32, 64, 128. What you do, you just write down these digits. Okay, you just write 0, 1, 0, 0, 0, 0, 0, 1. Once you write down the digits, you just need to add the numbers above ones, guys. Above the 1 we have 64 here. Above this one we have 1. So 64 plus 1 is 65. So we have successfully converted the binary number to a decimal equivalent, guys. Let's write down these digits. I write down here 1, 1, 1, 1, 0, 0, 0, 0. Let's add the numbers above ones. 8 plus 2 is 10, 10 plus 4 is 14, 14 plus 1 is 15. So 15. That is how you convert a binary number to a decimal equivalent. Let's convert this. I write down here 0, 0, 1, 0, 0, 0, 1, 1, guys. Above 1 we have 32. Above this one we have 2. Above this one we have 1. So 32 plus 2 is 34. 34 plus 1 is 35. 35. So 0, 0, 1, 0, 0, 0, 1, 1 indicates 35, guys. Let's convert this. We write 0, 0, 0, 1, 0, 0, 0. Above this one we have 32. Above this one we have 8. So 32 plus 8, 40. Let's convert this. 1, 0, 0, 0, 0, 0, 0, 0. So what is this binary number indicates, guys? We have 128. So it indicates 128 in decimal number system. So that is how you convert any binary number to a decimal equivalent number, guys. I hope you guys have clearly understood. You can convert a binary number to a decimal equivalent using one more method, guys. Let's try that here. I say Control A and say delete. Let's convert 1, 1, 1, 1, 0, 0, 0, 0 to decimal number. So what do we do is, we write down something like this. We write 1 multiplied by 2 raised to the power of 0. We start with 2 to the power 0, guys. Plus 1 multiplied by 2 raised to the power of 1 plus 1 multiplied by 2 raised to the power of 2 plus 1 multiplied by 2 raised to the power of 3. We can discard zeros present before the leftmost one, guys. You can just discard zeros before the leftmost one, guys. You can just write down like this. Next, what we do? We are going to evaluate this expression. 1 multiplied by 2 to the power of 3 is 8 plus 1 multiplied by 2 to the power of 2 is 4 plus 1 multiplied by 2 to the power 1 is 2 plus 1 multiplied by 2 to the power 0 is 1. 1 into 8 is 8 plus 1 into 4 is 4 plus 1 into 2 is 2 plus 1 into 1 is 1. 8 plus 2 is 10, 10 plus 4 is 14, 14 plus 1 is 15, guys. So 0, 0, 0, 0, 1, 1, 1, 1 indicates 15. That is how you convert a binary number to a decimal number equivalent, guys. I say Control A and say delete. Let's try some other number, guys. Let's try 1, 0, 0, 0, 0, 0, 1. Let's convert this binary number to decimal number equivalent. How do we convert this binary number to a decimal equivalent, guys? We write 1 multiplied by 2 to the power 0 plus 0 multiplied by 2 to the power 1 plus 0 multiplied by 2 to the power 2 plus 0 multiplied by 2 to the power 3 plus 0 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 5 1, 2, 3, 4, 5. 1 multiplied by 2 to the power 6. If you see here, 2 to the power 6 is 64, right? So 1 multiplied by 2 to the power 6 is 64. 0 multiplied by anything is 0, plus 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 1 multiplied by 2 to the power 0 is 1, guys. 64 into 1 is 64, plus we can discard these zeros, plus 1. So 64 plus 1 is 65. That is how you convert a binary number to a decimal equivalent, guys. I hope you guys have clearly understood. I think for this video tutorial, this much is enough, friends. I suggest you people to watch this video again and again. Understand decimal number system and binary number system. Understand how to convert decimal number to a binary equivalent number and a binary number to a decimal equivalent number. Try some more examples, because if you understand how to convert decimal to binary and binary to decimal, then you can definitely understand bitwise operators in C successfully, guys. I think for this video tutorial, this much is enough, friends. In the upcoming video tutorials, we are going to discuss more about C operators. For more benefits and be up to date, please subscribe to my YouTube channel. Don't forget to like, comment and share these videos with others so that everyone will get benefited. Keep learning, keep coding, keep sharing. Thank you guys. Thank you very much. See you in the next tutorial.